Special right triangles. Our objectives in this lesson is to be able to find the side lengths of special right triangles. These are right triangles whose acute angles measure 45 degrees, or 30 and 60 degrees. Let's begin by taking a look at using the Pythagorean theorem to find the missing side length. Now, this is probably not typed in your notes, so just sit back and watch right now. So just for this first right triangle, notice this side says 3 and we have congruent marks. So we know right away that this other leg is 3. Then we can use the Pythagorean theorem, c squared equals a squared plus b squared, to find the missing hypotenuse. Remember that the right angle points like an arrow across the triangle to show us the hypotenuse. So c is the one we don't know. We can call it x. X squared equals 3 squared plus 3 squared. So x squared equals 9 plus 9. And because 9 plus 9 is 18, then we will be taking the square root of both sides, normally writing plus or minus, but because this is a side length, it can only be positive. So x will equal the square root of 18. Now, 18 is not a perfect square, but there is a perfect square that divides evenly into 18. That is 9. So we can rewrite this as the square root of 9 times 2. Well, the square root of 9 is 3, with the 2 left over in the radical. So simplifying means that our hypotenuse is 3 times the square root of 2. Now, for any right triangle where we know two sides, we can always use the Pythagorean theorem to find the missing side length. However, there is a pattern. Anytime we have an isosceles right triangle, the two legs will always be congruent. Of course, that's what isosceles means. And the hypotenuse will always be whatever that leg measure is times the square root of 2, because we have two of the same leg measures. So today is a way to learn how to take shortcuts and not have to use the Pythagorean theorem every time. And this works for any isosceles right triangle. Now I've brought out two other isosceles right triangles. Let's say that these legs are 5 and 5. According to the shortcut, that means our hypotenuse is 5 times the square root of 2. Let's say these legs are 2 and 2. That would mean our hypotenuse is 2 times the square root of 2. These three triangles are all similar to each other. Well, we know that these angles are congruent. They're both 45 degrees. That's how we add up to 180. And when these two legs are congruent, these are also 45 degrees. And since these legs are congruent, these are also 45 degrees. So by the angle-angle similarity postulate, of course, we have similar triangles. Similar triangles, of course, means proportional sides. So I could take the side lengths, this side length over this side length, for example, 5 over 2, and it would equal the other pair of corresponding legs, and it would equal the pair of corresponding hypotenuses, 5 square roots of 2 over 2 square roots of 2. How do we simplify that? Square root of 2 divided by square root of 2 cancels out, and see, 5 square root of 2, 5 over 2 equals 5 over 2 equals 5 over 2. So we're going to use the shortcut by also using proportions. Let's remember the isosceles right triangle, or the 45, 45, 90 ratios of sides. 1, 1, square root of 2. How can we use that? For example, find the missing side lengths for each triangle. So in this picture, I see a 45 and a 90. So I know right away this is also a 45-degree angle. 45, 45, 90 triangle means I have two congruent sides. So this is also 10. The hypotenuse is, of course, just 10 times the square root of 2. Remember, the ratios of the sides is 1, 1, square root of 2. 1 and 1, meaning these two sides are the same, congruent, and the hypotenuse times square root of 2. Now this is a simple one, but when it gets more complicated, like in number 2, let's look at a way that we can use our ratios to make it a little bit easier. I'm going to notice, first of all, that it's a 45-degree angle and a 90-degree angle, so this is a 45, 45, 90 triangle. I'm going to write the ratios of the sides on the inside of the triangle. 1, 1, square root of 2. Now I remember that these two sides are congruent, so right away I know the other side has to be 3 times the square root of 2. But how about the hypotenuse? Well, let's put an x there. Now I'm going to make a ratio and then a proportion. So from the given side, I'm going to do inside number 1 over outside number 3 square roots of 2 equals, so following that same pattern, inside over outside, and I have to find x, that's on the outside. I'm going to put x down here because that's an outside number, the inside number in the numerator. How do we solve a proportion? That's right, cross multiply. So 1 times x is x, 3 square root of 2 times square root of 2. What does that look like? 3 square root of 2 times 2 is 4. And what is the square root of 4? 2. Another way to think about that is square root of 2 times square root of 2 is just 2. And then 3 times 2 is 6. So that missing side up here is 6. See? Not so bad. So let's remember, inside number in the numerator, outside number in the denominator, and we'll always get it. Go ahead and highlight that note to yourself so that we always remember setting up the ratios and proportions in that manner. Let's try another one. I see a 45 and a 90, so I know this is 45 degrees as well. I'm going to write for the two legs, 1 and 1, and then the hypotenuse square root of 2 in the inside. Now, the leg is what I need, and I know the legs are the same, so I'm going to call them both x. Let's set up our ratios and our proportion. Inside number over outside number. Inside number, square root of 2 over outside number, 12 square root of 2, equals inside number over outside number. Now, sometimes we like to simplify the ratios before we cross multiply if we can. And I see a square root of 2 over a square root of 2. That's going to leave 1 in the numerator. Now when I cross multiply, 1 times x is x, and 1 times 12 is 12. Done. X equals 12. So these two legs are both 12. One more. Again, I notice two sides that are congruent. That means I have to have 45 degrees for the missing angles since that's a 90-degree angle. Let's go ahead and put x for both of those legs. And then because it's a 45, 45, 90, we'll put 1 and 1 on the insides of the legs and square root of 2 on the inside of the hypotenuse. Now let's set up our proportion. Inside number over outside number. Square root of 2 over 18 equals inside number over outside number, 1 over x. Now we can cross multiply. X times square root of 2 equals 1 times 18. How do I get x by itself? Divide by square roots of 2. I'm left with x equals 18 over the square root of 2. That is a fine answer for each of those legs. 18 over square root of 2. Now sometimes you'll see it rationalized. What does that mean? I'll show you. 18 over square root of 2. Rationalizing means we don't leave a radical in the denominator. So I'm going to show you how to do that in case you ever need to know. Rationalize. We're going to multiply by square root of 2 and square root of 2 in the denominator and the numerator. Why do we do that? Because square root of 2 times square root of 2 is just 2. So this equals 18 square root of 2 in the numerator over 2 in the denominator. Now I can divide 2 into 18 9 times. So finally, I'm left with 9 square root of 2, which is another way to write that answer. 9 square roots of 2. Pretty cool, right? Thanks for watching.